Chapter 8. He snatched the lightning from the heavens. Franklin recorded that during the 1740s his business was continually augmenting and my circumstances growing daily easier. By 1748, his circumstances had in fact grown easy enough that he decided to withdraw from active involvement in the printing trade. In the summer of that year, he formed a new partnership with David Hall, his shop foreman. Hall would run the shop, publish the Pennsylvania Gazette and Poor Richard's Almanac, and pay Franklin 50% of the profits. After 18 years, Hall would become full owner of the business. A letter to a friend shows that the senior partner was pleased with this arrangement. I congratulate you on your return to your beloved retirement. I, too, am taking the proper measures for obtaining leisure to enjoy life and my friends more than heretofore, having put my printing house under the care of my partner, David Hall, absolutely left off bookselling and removed to a more quiet part of the town, where I hope soon to be quite master of my own time. Thus, you see, I am in a fair way of having no other tasks that such as I shall like to give myself, and of enjoying what I look upon as a great happiness, leisure to read, study, make experiments, and converse at large with such ingenious and worthy men as are pleased to honor me with their friendship or acquaintance, on such points as may produce something for the common benefit of mankind, uninterrupted by the little cares and fatigues of business. Upon his retirement, Franklin's annual income from his several business partnerships, his position as postmaster, his real estate holdings, and the interest on his savings probably exceeded that of the Pennsylvania governor. At the age of 42, he knew he was entering a new phase of his life, and he wanted his remaining years to be as serviceable to his fellow men as possible. Now that Pennsylvania was no longer threatened by hostile forces, and Franklin was no longer bothered by the cares and fatigues of business, he turned his attention once more to electrical experimentation. In addition to the terms positive and negative, he coined several others that are used widely today. Armature, battery, brush, charge, condense, conductor, electrical shock, and electrician are some examples. He also developed the first electrical battery and invented the lightning rod, for which he refused any patent or profit. He produced the first coherent theory of electricity, that of a single fluid in positive and negative states. He even experimented with shock treatments as a means of curing certain bodily disorders. By this process, he apparently healed a young woman who had suffered cramps and violent convulsions for 10 years. There were some dangers associated with Franklin's electrical experiments, of course. He told Peter Collinson about a frightening occurrence in December 1750. I found that a man can without great detriment bear a much greater electrical shock than I imagined, for I inadvertently took the stroke of 2 of those jars through my arms and body when they were very near fully charged. It seemed a universal blow from head to foot throughout the body, and followed by a violent, quick trembling in the trunk, which gradually went off in a few seconds. It was some minutes before I could collect my thoughts so as to know what was the matter, for I did not see the flash, though my eye was on the spot of the prime conductor from which it struck the back of my hand. Nor did I hear the crack, though the bystanders say it was a loud one. Nor did I particularly feel the stroke on my hand, though afterwards found it had raised a swelling there. My arms and the back of my neck felt somewhat numb the remainder of the evening, and my breastbone was sore for a week after, as if it had been bruised. What the consequences would be if such a shock were taken through the head, I do not know. But his obsession to learn drove him on in spite of the danger. One of the episodes for which Franklin is best remembered is the daring experiment with his famous kite in the summer of 1752. Although he was not the first scientist to suggest that lightning and electricity were identical, he was the first to design an experiment that could prove it. He conceived a method for verifying the hypothesis in 1749, and in 1751 it was published, along with his other writings about electricity, in America, England, and France. A French physicist named D'Albard, after studying the proposal, successfully conducted the experiment on the outskirts of Paris in May 1752, actually a month before Franklin himself tried it in Philadelphia. Franklin believed that lightning could be attracted by a pointed metal rod, as could other electrical currents, and he was waiting for a high tower or spire to be built in Philadelphia, one that was high enough to enable him to test his idea. Then it occurred to him that he could accomplish his end perhaps even better by means of a common kite. The following account of his memorable experiment is taken from Joseph Priestley's History and Present State of Electricity, written under Franklin's close direction and published in 1767. Preparing a large silk handkerchief of 2 cross sticks, a proper length on which to extend it, he took the opportunity of the first approaching thunderstorm to take a walk in the fields in which there was a shed convenient for his purpose. But dreading the ridicule which too commonly attends unsuccessful attempts in science, he communicated his intended experiment to nobody but his son, who assisted him in raising the kite. William was now 21 years old. The kite being raised, a considerable time elapsed before there was any appearance of it being electrified. One very promising cloud had passed over it without any effect, when at length, just as he was beginning to despair of his contrivance, he observed some loose threads of the hempen string to stand erect and to avoid one another, just as if they had been suspended on a common conductor. Struck with this promising appearance, he immediately presented his knuckle to the key, and let the reader judge of the exquisite pleasure he must have felt at that moment. The discovery was complete. He perceived a very evident electric spark. Others succeeded even before the string was wet, so as to put the matter past all dispute, and when the rain had wet the string, he collected electric fire very copiously. This happened in June 1752, a month after the electricians in France had verified the same theory, but before he heard anything they had done. Following the 1751 publication of Franklin's scientific writings and D'Albert's experiment in 1752, the German philosopher Immanuel Kant called Franklin the Prometheus of modern times, and many other honors and praises poured in from throughout America and Europe. He was awarded honorary graduate degrees by the College of William and Mary in Virginia and by several large universities, Yale, Harvard, and eventually St. Andrews in Scotland and Oxford in England. Thus, without studying in any college, he said, I came to partake of their honors. This is how he became known as Dr. Franklin, despite only 2 years of formal schooling. In 1756, he was elected to the Royal Society in London and was presented their gold medal for distinguished accomplishment. Even the King of France sent his thanks and compliments in an express manner to Mr. Franklin of Pennsylvania for the useful discoveries in electricity. In describing his reaction to all this attention, Franklin compared himself to a girl who was observed to grow suddenly proud, and none could guess the reason till it came to be known that she had got on a new pair of garters. Much of the recognition given to Franklin resulted from his work in electricity, but his studies, experiments, and writings actually contributed to, and sometimes pioneered in, many scientific fields. His broad range of inquiry included meteorology, physiology, medicine, chemistry, mathematics, botany, agriculture, geology, natural history, mechanics, and physics. In addition to those we have already noted, his inventions included bifocals, the flexible catheter, and daylight savings time. He experimented with the influence of color on heat absorption and with the capacity of various mediums for conducting sound waves. His investigations in evaporative cooling anticipated the principle of electric refrigeration. He helped organize the first American expedition to the Arctic under Captain Charles Swain in 1753, and in his later years he developed a theory on the formation of the Earth. Although Franklin's increasing public responsibilities denied him the time to pursue his many scientific interests as systematically and thoroughly as he would have liked, he continued to study and experiment because he believed that the quantity of human knowledge bears no proportion to the quantity of human ignorance, and that new discoveries could significantly improve the human condition. More than 20 years after Franklin's death, Thomas Jefferson wrote that his contributions to science were so highly esteemed throughout the Western world because he always endeavored to direct them to something useful in private life. And that's the end of chapter 8.